Hello everyone and welcome to today's discussion on the week 4 assignment. And today, since we couldn't hold the class, I will just be discussing the solutions. Sorry, I won't be able to take questions live now, but if you have any questions, you can get back to me in our next week's assignment discussion, that is on next Tuesday, regular time, 6 to 7 p.m. on Tuesday. So for now, let's just get on with our with the discussion on the current assignment. So the week 4 assignment was to do with probability distributions, expectation values, and some operations on sets. Okay. So let's see what the questions were actually. The first question asks us to calculate the expected value of a random variable x whose distribution was given as follows, that is -4 occurred with a probability of 0.25, -1 occurred with a probability of 0.1, 4 occurred with a probability of 0.5, and 6 occurred with a probability of 0.15. To calculate the mean of this random variable, all you need to do is just use this formula, that is mean is the summation of pi xi, where pi is the probability of occurrence of element xi. For this specific example, the solution is you just need to multiply uh, each of the given values of the random variable by its probability, and that is nothing but -4 into 0.25 minus 1 into 0.1 and so on, and just add those. And by doing that, you get basically this expression, which equals 1.8. So the answer to the first question is 1.8. Next question is a little more theoretical. Given that A and B are two independent events, which of the following statement is correct regarding their probability? We know that P of when two sets are independent, A and B, then P of A B is equal to P of A into P of B, which is the first occurrence. Now, the other things are, if you look closely, P of A complement into P of B is not independent actually, because P of A complement is nothing but P of B. If A and B occupy the entire sample space, so P of B is not independent of. So P of A complement will equal P of B if P of A plus P of B equals 1, and in that case, these two sets are not independent of each other. That is P of A complement into and P of B. They are actually the same set. Likewise, P of A B complement will be equal to P of A, and since P of A and P of A are not independent, you just simply can't multiply them. So the answer to the second question, that given A and B are two independent sets, then only this holds true, that is P of A B equals P of A into P of B. Now the third question is, how many ways can the letters A, B, C, and D be combined? To do this, let's do this small logical exercise. Now we need to fill 4 blanks, that is these 4 blanks with the letters A, B, C, or D. Now how will you fill the first blank? Given 4 letters are at your disposal, the first blank can be filled in 4 ways. The second blank can be filled only in 3 ways, since we have already used one of these letters in the of A, B, C, or D. Likewise, the third blank can be filled in 2 ways, and the fourth blank can be filled in only 1 way, since will be having only 1 letter remaining. So the answer to this question is basically combine all the ways you can fill each of these blanks, that is 4 into 3 into 2 into 1, which is nothing but 4 factorial, and this gives you 24. On the same line, I would encourage you to think about this question, and maybe we can discuss this in the next class. As given, in how many ways can you make 4 letter strings? Strings are nothing but these just a series of blank spaces wherein you can fill these letters in. How many 4 letter strings can be made with the letters AA and BB? We'll discuss this in the next class, and let's see how you attempt to solve this question. But the answer to this question is nothing but 4 factorial, that is 24. Uh, the next question is, given a sample space of A, B, C, D, E, that is a sample space of 5 letters, and what is the probability of event E1, that is A occurring, that is nothing but 1 by 5, because A occurs only once in this letter of 5 uh, total number of events. So 1 by 5 is nothing but zero point 0.2. And what is the event of E2 occurring? E2 is G. G is not in the sample space, so it cannot occur. So the probability of E2 happening is 0. Next is again a combinatorial question. And how many different ways can you choose 4 students in a class of 10 for participating in a quiz competition? The easy answer and a very formulaic answer to this is nothing but uh, 10 choose 4, which is nothing but 10 factorial divided by 4 factorial into 10 minus 4 factorial, which is this expression. You can, yeah, you can just use this formula directly and you get an answer as 210. But to solve it logically, you can think of it in the following manner. As we did in the previous question, you can choose the first person in 10 ways, since there are 10 students, second person in 9 ways, third person in 8 ways, and fourth person 7 ways. So the total number of ways you can choose 4 students out of 10 is basically 10 into 9 into 8 into 7. Sorry, this should be 7. Okay. And then let these students be called A, B, C, D. Now you can see that once you have chosen them, you can choose this you can arrange these 4 students in 4 factorial ways. Okay. Let's call this, yeah. But since we are only interested in choosing them and not arranging them, we need to account for this uh, arrangement as well, and we need to discard this. So we don't take order in consideration. So when we don't take care about order while choosing, in the order in which we choose these students, we need to account for this disregard for order, and that is done by dividing this expression here, that is 10 into 9 into 8 into 7, by 4 factorial, because you can arrange these students A, B, C, D in 4 factorial ways. So we need to disregard that. To do that, we just divide whatever we got, that is 10 into 9 into 8 into 7, divided by 4 factorial, which gives us 210 as the answer. It is a little tricky to understand this logic. If you have any questions, please get back to me in our next class. But if you guys are more used to just using our direct formula to answer this question, it's 10 choose 4. But I would urge you to use such kind of logic while answering this question, because this is more like solving answers using a first principle basis. The next question is, an experiment consists of tossing a coin 4 times. What is the number of events in the sample space? Now you all know that once you toss a coin, you can have 2 outcomes, that is head or a tail. So when you toss a coin n times, we will have 2 power n outcomes. For example, if you toss a coin twice, the first time you can get head or a tail, and the second time also you can get a head or a tail. So if you combine these all possibility of outcomes, you get like 4 outcomes. So it's nothing but when we toss a coin n times, you have 2 power n outcomes. Now here you the question is, when you toss a coin 4 times, then that means n equals 4. Then the number of outcomes possible is nothing but 2 power 4, which is 16. Next question is, given A and B are 2 independent events, and which of the following statements is correct? So we know that this need not be necessarily true, but one thing that can happen when will happen when A and B are 2 independent events is that uh, we know that P of A given B is P of A intersection B divided by P of B. This comes from our conditional probability formula. And since A and B are independent events, P of A intersection B is nothing but P of A into P of B. Therefore, P of A given B is nothing but P of A intersection B by P of B. Now, if you substitute this P of A intersection B as P of A into P of B, you get this in the above, and divided by P of B, and P of B get cancelled, and you remain only with P of A. So when P of A and B are two independent sets, then P of A given B is nothing but P of A. Uh, Next is, given A and B are two independent events, P of A equals 0.3 and P of B equals 0.8. What is P of A complement into B complement? Uh, to answer this, there are multiple ways. I've just chosen one. You know that P of A complement is nothing but 1 minus P of A, and P of B complement is nothing but 1 minus P of B. So P of A complement into P of B complement is 1 minus P of A into 1 minus P of B. If you simplify this, you get this expression, that is 1 minus P of B into minus P of A plus P of A into P of B. And when you simplify this further, you get this, which is nothing but 0.14. Okay. An assumption that is required while answering this is that P of A complement in B complement, the sets are independent. If both these sets are also independent, which may not be necessarily true. Okay, but here we need to consider that P of A complement and B of P of B A complement and B complement are independent events. Uh, then we move on to our next question, that is, compute the variance when E of x square is given and E of x is given. So variance is nothing but this, that is E of x square minus E of x square. This is the second moment that we calculate of any random variable, and substituting the values, E of x square is given as 61 by 4 and E of x is given by as 7 by 2. So when you solve this, you get 61 by 4 minus 7 by 2 the whole square. That is nothing but 12 by 4, which is equal to 3. And the last question is, which of the following statements is true? Let's solve for this. What's E of expectation of Ax plus B can be written as, you can separate it because it's in a linear form. So E of Ax plus B is nothing but E of expectation of Ax plus expectation of B, where A and B are constants. Now, expectation of a constant is the constant itself, so expectation of B is B. And when you have expectation of a constant multiplied by a random variable, you can take the constant out and just multiply by the expectation of the random variable, which is E of x, which gives us E of Ax plus B is nothing but A into E of x plus B, expectation A into expectation of x plus B, which is the fourth option, and the others are not true. So that brings us to the end of the discussion for this assignment. Sorry, I could not hold this class because I was traveling. But if you have any doubts pertaining to this assignment, we can discuss them in the next class. Also, I'll be asking you the answer to that question I posed earlier as to what, uh, yeah, given 4 letters A and B, how many 4 letter strings can be formed? Just to give you a flavor of combinatorial. And yeah, let's meet in the next class, Tuesday, 6 p.m. India time. Yeah, see you all, and bye bye. Thank you so much.